Okay, so we're going to talk about savings annuities, and there's actually a formula for this. So the situation for a savings annuity is that we're going to put some fixed amount into an account which earns some amount of interest each time period. And we're going to do this for a certain number of years. So I highlighted these different pieces because I'm going to show you where these pieces kind of show up in the formula. So the fixed amount that we're putting into the account each time period is going to be this P. And then our interest rate is going to be R in our formula, so that shows up in two spots. The number of time periods is going to be N. And specifically, I'm going to make a comment that these time periods, N, is going to be the number of time periods each year. So, for example, if I were to compound each month, then I would have N be 12 for 12 times a year. If I were to compound each week, then it would be the number of weeks in a year, so 52. If I were to compound just once each year, then N would be 1. So here are the different spots where N shows up. And we're going to do that for a certain number of years. And T in our formula is going to be the number of years. So if you have all four of these pieces of information, you can plug it into this formula. And this A that pops out is going to be the amount in the account, so the ending balance. After doing this for so many years, right? Well, sometimes we're not trying to solve for the ending balance. Sometimes we have like a goal ending balance and we're trying to figure out, okay, how much do I need to put aside each month or each week or each year, whatever the time period is, each time period, so that I can save up this amount of money in so many years. And so what we can do is just rearrange this formula. So literally all I've done is rearrange the formula. It's not a new formula, it's just algebraic manipulation. And if we look at this kind of way that it's written, then we have the amount that we put aside each month as P is equal to A, which is our goal ending balance, basically, times R. Sorry, I'm trying to get the color coding right. R is right here. And then we have our time periods as N again. And then we have our number of years right there. Okay, and again, this A is our ending balance, right? In the first formula, that kind of structure of the formula is good for when we know how much we're putting aside each month and we're trying to figure out what is our ending balance going to be, right? Like that's the question. What's the ending balance? This second formula is good when we're like, well, we have a goal ending balance and I want to make sure that I get that ending balance in a particular number of years, and so I'm trying to figure out how much my payments or deposits should be. So here we have an example. We're trying to figure out how much we would have to set aside each month into an account earning 4% APY to save up $100,000 in 10 years. So we're trying to figure out the amount that we need to deposit each month. So we're trying to figure out this P number. Well, we can reference this formula up here and know that I'm going to take my goal amount, which is $100,000, and I'm going to multiply this by my interest rate, 0.04, because I'm writing that percent as a decimal. And I'm going to divide out by, I'll have N, which if we're setting it aside each month, and we're going to make the assumption that then the account is compounding once a month, Our n would be 12. And so then we have this. So 1 plus 0.04, our interest rate again, divided by 12, raised to the 12 times. Now, it says that we're doing this for 10 years, so t would be 10, and then we have minus 1. And so now, we just need to make sure that we type this into a calculator correctly, which I'm going to do right now. And we end up getting $679.12. So this is how much we need to set aside each month if we want to save up $100,000 in 10 years.